Hello there, Nareg is here. Today I'm going to solve the second exercise of chemistry, second session 2019. The second exercise is related to electrochemistry, so let's start. Aluminium zinc cell. Redox reactions involve the transfer of electrons from one chemical species to another. In the laboratory, a group of students construct an aluminium zinc electrochemical cell, it's called G, in order to study the variation in mass of the zinc strip during the functioning of this cell. Document 1 is a bar graph that represents the obtained result. Refer to document 1, answer the following questions. Show that zinc strip is the cathode of the cell G. Very simple. We're going to refer to document 1. We have, before the functioning of the cell, the mass of zinc is 3. After a certain time of functioning, the mass has become 3.2. So whenever the mass is increasing, it means that there is a reduction which is going on. So we have zinc, which is going through a reduction equation or reduction reaction. And of course, I'm being able to transform the zinc ions to zinc, which is solid, and that's why the mass will increase. So this is how you can say that from 3 to 3.2 the mass is increasing actually. That's why this strip is the cathode, since it's going through a reduction. Identify among the metals, zinc and aluminium, the one that has the greatest tendency to lose electrons. Now, since zinc is the cathode, so whatever remains for the aluminium is the anode. So whenever aluminium is the anode, aluminium will have the higher tendency to lose electrons. The anode is the metal which is more likely to lose electrons in a much more easy way. So anode, it will be the strip of aluminium, and it will have a higher tendency to lose electrons. A grade 9 student schematizes the cell G constructed by his classmates. Pick out from the adjacent schema the errors committed by the student, justify. So we have to check. The aluminium strip is actually placed in a solution containing Al3 plus ions, so that's great. The zinc strip is placed in a solution containing zinc ions Zn2 plus ions, so this is also great. Now, what about the orientation of the electrons? The electrons should move from the negative pole of the cell towards the positive. So it should move from aluminium strip towards zinc strip. So this is the direction which should be considered for the electrons, and not the one which is already placed on the schema. As for the salt bridge, we have in the part where we have the anode, which is going through a certain oxidation, the concentration of Al3 plus is increasing, so the positive charges are increasing. I need negative charges to do a certain equilibrium, so NO3 plus should be moving towards this part, the anodic part of the cell. As for K plus, it should be moving towards the part where I have the cathode, since Zn2 plus, the ion of zinc, is being transformed to Zn, so the positive charges are decreasing in the solution. I need to find a certain equilibrium. That's why K plus should migrate and be transferred to this part of my cell. So these are the two errors. Write the oxidation and the reduction half reaction of the cell G. So we're going to write down the oxidation. We know that it's happening with the strip of aluminium, so we have Al being transformed to aluminium ion 3 plus 3 electrons. As for the reduction, this is the half equation of oxidation, half equation of reduction. In this case, I have the zinc ions, where they gain a couple of electrons and they will be transformed to zinc solid. These are the half equation of reduction, half reactions of oxidation and reduction. Deduce the overall equation of the reaction of this cell. Now, I'm interested in finding out the overall reaction. You have to pay attention. You should have the number of electrons on the left side and the right side of your half equations the same. We have 3 and 2, they are not equal. That's why I need to multiply this equation by 2, and I need to multiply this equation by 3 in order to have 6 electrons. So I will have Al, 2Al, which gives me 2Al3 plus 6 electrons, and I will have 3Zn2 plus 6 electrons, which gives me 3Zn. Now the overall reaction, I should add them, so I will have 6 and 6, they will cancel out. 2Al plus 3Zn2 plus, it gives me 2Al3 plus 3Zn. So this is the overall equation of the reaction which is going into the cell represented by the schema. That's all for this second exercise from second session 2019 chemistry. I hope it was helpful, so I'm gonna ask you to subscribe to my channel because I'll be uploading new material. I will be solving new sessions, different exercises, so you'll be notified. And I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you later.